Today I want to talk to you about the last mile problem of AI evaluation. So just so I level set a little bit, how many folks are building LLM or AI applications in the room? A sizable chunk. Some who are kinda. And how many have thought about evals or heard of LLM Judge or are struggling to get things into production? Okay, excellent. So I think we're in the right room then. And so I just want to level set a little bit. Like evaluation in the AI application space simply means, how do I measure if my AI application is performing well? And it's not just the LLM. Oftentimes it's a complex system like a multi-agent application or a RAG pipeline. And so there are multiple components to this, and all of that leads to complexity and difficulty in figuring out if things aren't working well, where did things go wrong? And being unable to answer this question of, is my application doing a good job, is usually the biggest blocker that we've seen for companies to be able to productionize their application and put it in front of users. And the reason it's difficult is AI applications, unlike traditional software engineering, introduce non-determinism as a feature, not a bug. And so in order to test and evaluate those applications, it's fundamentally different than writing integration tests or unit tests for traditional software. And so we're trying to bridge that divide. And because LLMs and Gen AI development is pretty new, we're still developing new techniques and workflows for making that possible. And the current state of the art is you ask another LLM to judge the responses of your AI application, and that's called LLM as a judge. I'm sure folks who are building AI applications have already encountered that or trying that out. And you'll also probably see that that approach isn't perfect, because a lot of the times LLMs are missing context about your application, don't have the subject matter expertise, and they can also be slow and expensive. So evals need to be run like thousands of times, and sometimes it won't scale from a cost or efficiency perspective. And so what we're trying to do is really move beyond LLM as a judge style evaluation tasks. And the good news is evaluation is essentially a classification problem. And the classification problem is a binary classification problem. Like for every input to an AI system, you want to see if the response is good or bad based on some custom criteria that you have. So how do we model this as a classification problem? Well, first you provide the application data, like the trace data that of inputs, outputs, maybe context retrieved from a RAG application. Then you want to define an evaluation criteria, which in the LLM judge case is effectively a prompt. And then you want to basically get high quality labels of, are these examples good or bad in terms of your custom application evaluation criteria. What we're trying to do actually is this is where LLM judge today ends, right? What we're trying to do is move to the next step from there, which is let's fine tune an evaluator model that learns your evaluation criteria and is able to basically distill that learning and give you high quality metrics at the end. So I'm going to it's way easier to show than to tell. And so that's what I'm going to do in a second. But the other thing I just mentioned was LLM Judge has limitations where it doesn't understand your subject matter expertise or application specific context, but it's still very good at generating labels. And so what we can do is we can still start with a prompt. We can still say, hey, here's my evaluation criteria, and get some initial labels from an LLM, and then have an expert like you as a developer or someone who really understands the application refine those labels until you get a high quality data set. And once you have a data set, then it's just a distillation problem. Then you just fine tune a small language model, which we've developed one for specifically eval tasks. And then you can compute evaluation metrics with a custom model that represents your custom metric. And so what that looks like at from an application perspective is, let's say I have an application that's an AI dining concierge. So this is an assistant that's going to give me restaurant recommendations, essentially. So I can ask it for, let's say, a sushi place in downtown Toronto for a group of 4. And like you would expect, it's writing out an LLM response in natural language, and it give me a couple of examples of restaurants I can pick from. What you'll notice here are these 2 tabs called query analysis. And these are running these fine-tuned evaluator models for this application. So the right one is called relevance score, which is how relevant is the input question to the purpose of the application, which is dining. And so here you can see, if I'm asking for restaurants, for sushi restaurants in Toronto, that's pretty relevant to dining. And so you get a high score. And the second one is a safety score. So this AI dining concierge is part of a credit card application, and we want to deny anything related to like financial data from being asked by this application. So we want like a custom evaluator that kind of measures, is this a safe input or not? And in this case, it's deemed pretty safe. But if I ask like, can you reset my credit card PIN as an example, first, what you'll notice is the models are running really quickly. These are custom models. But the second thing is you get like the safety score shoots up and like says it's considered unsafe. And also the relevance score is like 0.1 out of 1. So it's showing that it's like pretty irrelevant asking for resetting your credit card PIN to an application about dining. And it also catches like ambiguous cases like, what's a good sushi place near me, and can I pay for it with my available credit limit, which is ambiguous because you're asking for both things. And so it's kind of relevant. You get a 0.4 score, but safety, again, is deemed unsafe because of the second half of this question. And so how do we create these kinds of models, right? And that's really what we're building at LastMile. So what you start with is, like I mentioned in here, you start with like providing your application data. And so you can upload application data to the platform. And here I have some examples here, like this is for the dining application I just showed, where it has inputs, ground truth of like in a RAG application, what the context retrieved is, and output that the AI application produced. And then what we want to do is generate LLM labels on this data set, which is basically what LLM Judge does today. So in this case, we have a few templates available, like for faithfulness, you would specify the input, output, and ground truth and ask the LLM to label 1 or 0 based on some criteria for hallucinations. And then essentially you get a labeled data set at the end of this process, and you can refine that through the platform with human intervention until you get until you're confident that the labels are accurate to your evaluation criteria. And so I have that created for like this AutoEval is a good question and answering data set. So I created a few of those and I labeled them ahead of time here. And so then what you can do is go into the model console, and we have a few base metrics available already. And so this is for, you have common application types like question answering applications, agentic applications. And so, for example, if your application is doing summarization, we have an out-of-the-box model available for measuring summarization score. And so here you have like the ground truth being a couple of movies, and you want to see is the output accurately summarizing that. And so you can run this model. And one of the things you'll notice is it runs really fast in like 300 milliseconds, and the model in the backend is running on CPU. And that's one of the things that you really want if you want to be able to run this in real time as well, potentially as a guardrail. And then if I change this, like let's say I change the movie name to Aliens instead of what it was, the score goes down as expected, like the summarization score is affected by that. And we have a couple of other models out of the box. Faithfulness is a good proxy for hallucination. So in this case, if I run this where you're asking what are the advantages of investing in an index fund, and you get a couple of like, you pulled something from a chapter 4 of this investment guide, it returns a high score. But let's change a very slight thing, like let's change it to chapter 1 instead of chapter 4. And you'll see the faithfulness model immediately, like it goes from 0.99 to 0.001. So it's able to catch like really ambiguous, very, very tricky cases where the data is unfaithful. And then what's really cool is now if I have a labeled data set, I can actually fine tune one of these models for my evaluation criteria. And it's all available via the API, but it's really just, you can click through a couple of screens on the UI and get a fine-tuned model. And so here, let's say I have like AutoEval custom faithfulness as my metric, and I select our base model. And then you can just choose your data set. And this is the application traces with the labels that were refined with an LLM judge. You use a test data set similar to any model training where you want to have a holdout set for testing and validation. And then which columns from your data, like what from your application trace data, do you want to include in the training process? And then you just submit the job, and it trains in actually less than 5 minutes. You can come by afterwards, and I can show you as well that's the case. You can track progress for it if you have weights and biases, etc. And then you can also, like, once it's ready for training, for inference, you're able to ask it questions. And so here we'll just like ask some like simple, silly question. What is the meaning of life? And if I just like enter these things, I can get a score. And again, this is like the score from a fine-tuned model that's been deployed for you is sub-second latency. It's 300 milliseconds on average latency that this works in. And so what that really allows you to do is generate as many of these training and evaluation metrics as you care about. And you can see already the training progress is 50% for the model we're training right now. And you can have as many of these hooked up into your application. You can use them as offline evals for test runs. But because of the speed and efficiency of these models, you can also hook them up in real time as guardrails. And the powerful thing about that is, instead of like detecting hallucinations after the fact, if you detect that at runtime and you're able to catch it quickly and cheaply enough, and then you can just prevent that from hitting the user in the first place. And so this basically what we like to think of as evaluation and guardrails, we think of them as two sides of the same coin. And this is almost like killing two birds with one stone by having fast, customized models that are able to work efficiently for both purposes. So I'll pause there. The last thing I want to show you is basically you can also track all of this in an application dashboard. And so you can like basically customize this with metrics that you care about and figure out how you want to measure application performance for your AI application. We're also, the cool thing is we're launching next week this platform called AutoEval. You can go to lastmileai.dev today and sign up, and would love your early feedback on some of this evaluation process. And we're excited about moving AI evals to be more of a science than an art. And so would just love your input and feedback and help us along there. And I also wanted to call out Lightning. We use Lightning for some of our model training workflows as well. And so thank you for building a phenomenal platform. That's it. And so you can find me afterwards, and I'd be happy to answer any questions. Thank you.